All right, here we just have a random selection of problems just for good practice. So let's find the area bounded by y equal x to the 2/3. Looks like this. And y equal x. Okay, draw this kind of carefully because I know they do intersect at 1. So they know that there will be an area bounded. So there it is right there. We're going to spin it around the x-axis. So this is center. Revolve it around the x-axis. We're setting up the integral only, drawing the rectangles perpendicular to the axis of rotation. So there we go. All right, so let's find, I see that it's a washer, so pi, outside radius squared, inside radius squared. I see that it's dx integration. All right, so let's find that outside radius. So the outside radius is going to be here all the way out to the x to the 2/3 graph. The inside radius will be here to here, center to the red line of x. All right, and where am I going to be building the rectangles from and to? I can see that it's going to be from 0 to 1. All right, let's do the next one. Y equal x to the 1/3, which you know graph looks like this. Again, y equal x. Oh, I see 2 areas. I think we can probably find one and double it. We're revolving it around the y-axis. So here, this is center. So let me draw the rectangles perpendicular to the axis of rotation. Again, I'm going to take just what's happening in here and double it. So I'll have 2 times pi, and then let's spin it around, outside radius, inside radius. So outside radius will be out from here, and inside radius is in there. So let's see. Outside radius, inside radius, dy integration, because I see this is how I built the rectangles. So outside radius will be from the y-axis out to the line. It is y equal x, so make sure I can put in x equal y. The inside radius will be from the y-axis to the function. This I'm going to need to solve for x equal, so that is y cubed equal x. So y cubed in there. So I am doubling it, so I just need to go from here 0 to where they intersect on the y-axis, and I can tell that it's going to be 1. All right, so here I have y equal root x, y equals 0. So y equals 0, you know, is this. Make sure you've got that down. And then and x equal 4. So x equal 4 looks like this. And I'm revolving it about x equal 4. So this is the center. Okay, so this is the area that's bounded. I'm going to be revolving it about this. So as I spin it, I see that this rectangle makes a disk. As I spin it around, this is not a washer. So volume will equal pi radius squared dy integration. So it is my job to figure out what this distance here, because that's going to be my radius. So everything gets measured from the x-axis, from the y-axis from here. So I go all the way out to 4, and I subtract off the function, which is, well, I might be tempted to put in root x, but then you remember, I can't put in root x because I've got dy. So if I solve this, I get y squared instead. All right. So now where am I going to be building rectangles from and to? So I need to set these two equal to each other, or think about where they intersect on the y-axis. So I can see I'm beginning at y equals 0, and I want to find out when x equal 4 runs into y equal root x. So x equal 4 into y equal root x, well, that gives me y equal 2. All right, last one here. So here I have y equal ln of x. Crosses here at 1, y equals 0. So y equals 0 here. Let me do this in red. Y equals 0. All right. Then x equal e. X equal e here. X equal e. Okay. So I am spinning it about y equals 6, which is much higher, up here. So y equals 6. All right, so I'm taking this area here and revolving it about here. So there we go. Okay, so the outside radius will be from here to here. This whole distance will be the outside radius. Then the inside radius will be from here to here. Okay, so volume equals pi, outside radius squared, inside radius squared is dx integration, because how I built the rectangles perpendicular to the x-axis here. All right, so the outside radius is this distance here, which is just going to be 6. The inside radius, I want to get this red distance, so I want to say go all the way up to 6 and subtract off the function. And the function is ln of x. Then I need to build rectangles from and to, well, I can see by the limits given to me, from 1 to e.